one OH group, just one OH group. If two carbohydrates, two sugars are the same, are in a similar structure, but for one OH group around a chiral carbon, we name such isomers as epimers. For example, D-glucose, D-galactose, D-glucose, D-mannose. The difference between D-mannose and D-glucose is about their OH group, the direction of the OH group for carbon number 2. The difference between galactose and glucose is about the direction of OH group around carbon number 4. The only difference between two types of sugars. Finally, the last subject about monosaccharides is about their reactions, various reactions of monosaccharides. The first one is oxidation. As you can see here, when an alkyl group it transforms, it changes to an acid. As you can see here, when an aldehyde group, is oxide, it changes to an acid group. This is an acid group, COOH. This is an acid group. We have a same process for ketone groups. So whenever we have a ketone or aldehyde group and we want to oxidize these groups, we then have a acid group. On the other hand, when an alcohol group or OH group oxidize, it transfers to an acid. We also have an acid. You can see here such reaction here. When CH2OH oxidize, this group transfer and change to an acid group, COOH. So, for sugars, for carbohydrates, this is the one of the most important reaction for sugars. When their functional groups, which are aldehyde or alcohol groups, oxidize, these groups change to acids. Both aldehyde and alcohol change to acid. Well, if we have a reaction about aldehyde, just the alkyl group reacted. So we have such molecules. We named it aldonic acid. Aldonic acid is a molecule which is produced from the oxidation of carbonyl functional groups. What are the most important carbonyl group in nature? Carbonyl group. How much carbonyl group is existed in the nature? Very good, very good. We have two carbonyl groups. The first one is aldehyde, and the next is well. So, if we have an oxidation reaction for aldehyde group, then we have aldonic acid. You can substitute the name of sugar instead of this part. For example, glucose change to gluconic acid. Gluconic acid. Glucose change to gluconic acid. The name of sugar substitutes with the ald part. For example, for galactose we have galactonic acid. For mannose we have mannoric acid, and etc. If we have an oxidation process in alcohol group, we name such sugar, such molecules as oronic acid, uronic acid. In Persian, oronic acid, uronic acid, uronic acid. So, uronic acid is a molecule which is produced from the oxidation of carbon number 6. Carbon number 6. Oronic acid. You can substitute the name of sugar instead of or before of this part. For example, for glucose we have glucuronic acid. For galactose we have galactronic acid. For mannose we have mannoric acid, and etc. And finally, if the reaction situations are completely rigid with the presence of acids, both aldehyde and alcohol group are oxidized, and we have a new molecules with both two oxidized groups. Both aldehyde and alcohol are oxidized and change to such molecules. We name these molecules as aldaric acid. Aldaric acid. So, after oxidation of sugars, we have three types of new molecules. The first one is aldonic acid, the next is uronic acid, and the last one is aldaric acid. For example, for glucose we have glucaric acid. For mannose we have mannaric acid. For galactose we have galactaric acid. You can substitute the name of sugar with this part. Glucose, galactaric acid. Mannose, mannaric acid. Galactose, galactaric acid.
Doctor, can you get it what's first and second?
Yes, you want more explanation? You want more explanation about this? Well, the first type of sugars, monosaccharide reactions, chemical reactions, is oxidation. Oxidation means a molecule gain oxygen, missed hydrogen, or missed electron. In oxidation, a molecule gains an oxygen, missed hydrogen group, or missed electron group. In contrast, in reduction, a molecule gain hydrogen, gain electron, or missed oxygen. So such type of reaction are typical reaction of oxidation. You can see that this molecule gain an O group, oxygen group. So in oxidation of monosaccharide, three different type of molecule will construct or will produce. The first one is oxidation of the first carbon or anomeric carbon or functional carbon, which is the aldehyde group. When the aldehyde group is oxidized, it changes to an acid. CHO change to COOH. This type of molecule named albonic acid. The next one is oxidation of carbon number 6. We name such molecules as urinic acid. So if the only carbon which is oxidized is carbon number 6, we have a new molecule named urinic acid. For example, glucuronic acid. And finally, if both functional group will be oxidized, we have a new molecule named aldaric acid. For example, for glucose, it is glucaric acid. Glucaric acid. So, three different parts of